All right, on to day 2 is going to be our volume of pyramids and cones. We have our right and oblique pyramids and our right and oblique cones. And no matter whether they are right or oblique, we're going to use 1/3 area of the base times the height. If you haven't seen it done before, if you have a cone with the same radius and height of a cylinder, then 3 of those cones will fit inside that cylinder. Same goes for pyramids. So if I want to find the height of the square pyramid, volume is equal to 1/3 area of the base times the height between the bases. And the area of our base is a square, so I'm going to have 1/3 of 16 times 16. And the height from the bottom to what would be the base up here at the vertex is 15. So I'm going to do 16 squared, and 1/3 of 15 is 5. So 16 times 16 times 5 gives me 1,280 cubic feet. Find the volume of the oblique cone. Our height will be this 16 over here. So I've got 1/3 area of the base times the height. And this is a circle, so it will be pi r squared. So pi times 10 squared times the height of 16. I'm going to go ahead and multiply all this out, and then we'll work on dividing by 3. So if I do 100 times 16, that's going to be 1600 pi over 3. That's not divisible by 3, so technically that would be the exact form. And then if you want to, you can go ahead and change that. It doesn't say to round it, but just in case you needed to, it would be 1676 centimeters cubed. I would stick with the exact form just as a default. Here's our oblique square pyramid. So our base is going to be a 7 by 7 square, which is 49. And for volume, it's 1/3 area of the base times the height. So there's our 49, and our height is 7.5. So I'm going to do 49 times 7.5 is 367.5, divided by 3 is 122.5 inches cubed. Find the volume of the equilateral triangular pyramid. So I'm going to draw this base out here just so we can get kind of a refresher. It is 8 by 8 by 8. Now, we didn't hit on this a whole lot, so I'm going to break it down into this AP over 2. Remember that we have our 30 and our 60. So our short side is x, and our long leg is x square root 3. So if I take this triangle down, so half of the side length is 4, and if I want to work back to the apothem, it's going to be divide by 3, attach root 3, so it'll be 4 square root 3 over 3 for our apothem. And if we're working towards our big B, we're going to do apothem times perimeter over 2. So this is going to be 4 root 3 over 3 times our perimeter, which will be 24, all of that over 2. Now, just take this a little bit at a time. I'm going to work with the denominators first, and the 2 will go into the 24 12 times, and the 3 will go into the 12 4 times. So now what I have is 4 root 3 times 4, which is 16 square root 3. That's all for the area of my base. Now we can go to our volume, 1/3 area of the base times the height. And I'm going to have 1/3 of 16 square root 3 and a height of 7. I'm going to leave the 1/3 out of it for just a little bit. 16 times 7 gives me 112 square root 3. And then when I divide that by 3, it's going to stay put. Our units, feet cubed. Don't forget that area of that equilateral triangle with that AP over 2. And the last one, find the radius of the cone below whose volume is 200 cubic millimeters. So I'm going to look at my volume, 1/3 base times height. In this case, my base is a circle, so it is pi r squared height times 1/3. And let's plug in what we know. So our volume is 200, 1/3 pi r squared, and it tells me that my height is 10. So let's break this all down and move it around. If I divide by 10, I now have 20 equals 1/3 pi r squared. I'm going to multiply both sides by 3 to get rid of that 1/3. So 60 is equal to pi r squared. This is where we're going to have to start rounding a little bit, and I'm also going to move it up here. So 60 is equal to pi r squared. Divide both sides by pi. And we'll have 60 divided by pi, which is about 19.1-ish. I'm going to leave it exact in my calculator for right now. And r squared, so when I take the square root of both sides, I end up with, let's say round it to the nearest tenth, 4.4 millimeters for our radius.